Welcome everybody. My name is Marjamäki. I founded the Cppcheck project in 2007. I've been working on it since then. I am the maintainer right now, Cppcheck project. I work full-time since a few years on Cppcheck. So this is an open source project, free for everybody to use, but we also have a premium version. But you don't have to pay it for the premium version. Use the open source version if that works fine for you. So the agenda for today is that first of all, I think that not enough people are using static analysis. There are surveys. Yeah. There are surveys that say that only 70% of the developers are using static analysis, and I think this is too low. So I want to motivate you to start using static analysis more. And I will show you a little about what security vulnerabilities that Cppcheck can find also. And then I will go on to the main topic for today, that is Cppcheck integration. Firstly in your IDE, then CI, and in other tools. And lastly, I will talk a bit about how you integrate clang-tidy into Cppcheck and describe why you would like to do that. So first, motivational here. I'm thinking strongly that everybody should use static analysis. So one way I know that not enough people are using Cppcheck is that we run open source Cppcheck on the Debian source code all the time. And we don't do this to find bugs in Debian, but we do this to test Cppcheck. And we find thousands of undefined behavior in Debian. And this is a proof, I believe, that many projects don't use Cppcheck. So I'm not so happy about that. But I feel that it is getting better. When I did this 10 years ago or so, there were many more warnings than it is today. So why don't people use static analysis? And I'm not fully sure about this, but I think it's because of usability. So configuration can take a lot of effort. For instance, if you have a non-standard code in your project, it may be quite difficult to configure a tool. But Cppcheck is very good at this. This is something we designed Cppcheck to handle. And another point is that you get many warnings with static analysis, and people don't know how to handle that. So if you have a project and you don't use static analysis, what do? I think it's a mistake to turn on all the warnings at once, because you will get lots of warnings. And many of those are not serious bugs. So for instance, you may get many warnings about unused variables, condition is always true, redundant assignments, and so on. I think these are very good warnings, but I don't think it's good if you get too many such warnings at once. There is always a danger to fix all warnings also. So if you turn on every checker at once and start fixing everything, there is a big risk that you will introduce bugs. Therefore, I believe that it's best that you only turn on the most critical errors first, like array index out of bounds and null pointer dereference and so on. Maybe you only get 2-3 warnings then, but that is a quite good starting point, I think. So why should you use Cppcheck more specifically? We will look now on security vulnerabilities. So every year there are thousands of vulnerabilities reported, and this should be decreased, I feel. I made an investigation earlier this year in March. So I wanted to see how many CVs can Cppcheck detect. And I looked at the vulnerability database. I picked all the CVs in latest 12 months. And this is quite a lot of CVs. And then buffer overflow is the top ranked most dangerous bug. So I started to filter down the CVs a bit here. So I only looked at CVs that has overflow in the keyword. And then I got 1,232 CVs. And many of these CVs was for proprietary code that I don't have access to. And many of those CVs was for other languages also. So I wanted to look at C++ projects that was open source, where I can easily download and look at the code. So I added a .cpp filter, so all CVs that contain .cpp in the description. Then I got 39 CVs. And to be able to run cppcheck on a CV and check if we find the actual bug, then I need some more details than just the whole project or something. Or the file name. I need a specific line and so on. So in many cases, if there was a git SHA provided in the CV, then I could see what the problem is, or if there was a pull request or something like that. So something very specific. And now I have 24 CVs. That looks promising. So I downloaded all the source code, run cppcheck on it, and then I check the results. So this is what happened. We found actually 7 of the CVs with the open source cppcheck tool. This is quite high number, I feel. And it's a bit frustrating. This could have been prevented so easily. You can also see that cppcheck Premium finds some of the bugs that open source doesn't find. And then there are white spots here also. These are false negatives. I did expect to have false negatives, and this is something we, of course, will work on to improve in the future. So many of the open source bugs that we found was of a kind format string. What is that? Here is an example from a real CVE. So you have a header buffer, and you read from a file into that buffer, and there is no bounds checking. So it can read as much as possible as it wants. So there are 6,169 such warnings in Debian. And I think that many are true positives. We have one known issue in this checker only. So it's one ticket we have in our issue checker. So now about how to integrate cppcheck in your development process. I strongly believe that you shouldn't run cppcheck as a separate tool. It should be built into your workflow, so it's executed automatically. And there are some places you can integrate it into. I would recommend that you integrate it into your IDE. The earlier you get warnings, and the faster and easier it is to fix. So we support many IDEs, and this is not the complete list. Then I would say it's mandatory to use cppcheck or static analysis in your CI and enforce that the static analysis is happy. And then for usability, I think it's a good thing to integrate in other tools like code review and so on. Integration is something that we actively work on, and I wouldn't say that we are finished today. There will be many more improvements in the coming years. But what has happened in the last year is that we have added a SARIF output format for cppcheck that will make it easier to integrate cppcheck results into various tools. So I have here GitHub, GitLab, and SonarQube as examples, but I'm sure that there are many more tools right now that support SARIF. So we have recently added a file filter equals plus option from cppcheck that simplify IDE integration. And then there was a cppcheck Eclipse plugin. It was not very well maintained for a couple of years, and we have now taken over the maintenance of this, and it was developed and maintained by Konrad Vinzus before, so many thanks to you. This Eclipse plugin is now active and working again. Then you can use, it is best if you can use the same configuration in your CI and IDE and so on. So one way to achieve this is to use a cppcheck project file. And this is something that you can easily create using the cppcheck GUI. It can create it and edit it and so on. And it provides most of the cppcheck warning flags settings. And you can, for instance, import project files into that project file. So you can, if you have a compiled commands.json, you can import that. If you have Visual Studio solution project or something, you can import that and so on. And then you can reuse this in your IDE and CI and so on to limit the amount of configuration you need to do there. So how do you use a cppcheck project file? On the command line, it's quite straightforward. You write -- project, and then by default, cppcheck will run analysis on the whole project. If you want to limit the analysis to certain files, you can use file filter. Before, it was a bit more tricky to use a project file in IDEs. There was not direct support for project files, and it was not possible to just add it as an extra argument. But nowadays, we can configure with extra arguments. You can provide the -- project, and then you can provide -- filter. And then if the plugin runs such a command that I show here, cppcheck -- project -- filter, and then a file name, then what cppcheck will do in this case is that it will load the whole project, all the settings, and then it will start to analyze the file that the plugin wants to analyze. And no other files will be analyzed. So I will show a few screenshots how you install, configure, and use cppcheck in VS Code. And the procedure is quite similar in other IDEs also. But it looks a bit different, but very similar. So for VS Code, we have many plugins, and these are open source projects. I don't recommend a specific plugin, so choose whichever one you like. And the next step after installation is to configure. And here you can specify the extra arguments. And if you see other arguments, configuration options here, of course, specify that as you want. And now you can run cppcheck in your IDE. And here I have made a small simple bug. And it is shown that you have a bug here. And different plugins, there are plugins that run cppcheck as you type. And that means that if you make a bug, then in a few seconds you will get a warning. cppcheck is executed then in the background, so you don't have to fear that it interferes with your editing. But other plugins only run when you save. So here in VS Code, this is how it looks when I hover over a warning. You have probably seen this many times. The cppcheck warning message is shown. And there is a light bulb there to the left. And if I click on that light bulb, then I will get some options. In this case, I get the option that I can suppress this warning. I can fix using Copilot, or I can explain the warning using Copilot. And I first try this to suppress. So this is what happens if I suppress the warning. It automatically inserts a comment here. And I wanted to provide a further explanation why I have suppressed it, so that my colleagues or team members, etc., understands why I suppressed this warning. So I wrote a comment after that. And the suppression and suppression comment, this is something that you can export into the XML report. And then you can generate a report with what suppressions you have and why you have suppressed various stuff. So let's say that this was a false positive. and then you upgrade cppcheck. And now the false positive is gone. What happens now is that you will get another warning from cppcheck that says unmatched suppression, because you have a comment in your code that is not needed. So you will be able to remove this then. Okay, if you instead on the light bulb would have clicked on explain warning, then this is what can happen. You get the explanation here to the right. And it's a quite good explanation in my opinion. It says that you're correct and shows the related source code, and this causes undefined behavior because str is empty, so str 0 is out of bounds. Looks reasonable to me. All right, the next step here I want to talk about is how do you integrate cppcheck results in various tools. So there is a new format a few years old called SARIF, and this is a common format for many tools that they can both export and import into this. And I think this is a good future way to export static analysis results into various tools. And it will, in the end, give you a unified interface for all your static analyzers into different tools. And I will quickly show how you use SARIF with GitHub. So this is a small, simple YAML code that can be used that runs cppcheck on a project and uploads SARIF results. So the first step here is to run cppcheck, and I just add output format equals SARIF. That generates SARIF output. Then I add a step that uploads a report. And with this little simple code, what it will look like, instead of looking through weird CI logs, you will get warnings directly in the GitHub interface. So when you or your colleagues review your PR, they will see the static analyzer warnings inlined in the review view. And GitHub has this functionality to dismiss alerts also, where you can select why you would like to dismiss certain. So it's like an extension to our suppressions. Okay, finally, I will talk about how you integrate clang-tidy into cppcheck and why you would like to do that. I think it's a good idea to use other tools also, not just cppcheck. You can use other static analyzers and, of course, other types of tools like sanitizer, I think, is very important, and fuzzer, and so on. There is a common complaint when I say this, that it's very hard to use several tools. You have to create many configurations, you have to use many plugins, you get many reports, and maybe you have to look in several CI logs to be able to spot the bugs. So it's not easy for the developers. In part, I think this will be solved in the future by SARIF. That means you don't have to look in strange CI logs to find warnings. To integrate clang-tidy and cppcheck, first of all, I want to say that I'm a cppcheck guy. So I work fully on cppcheck, and I don't work at clang-tidy at all. So if I say that clang-tidy is a good tool, it's an honest opinion. Don't take it with a grain of salt. So I feel that cppcheck and clang-tidy complement each other. We catch different bugs. We have different heuristics. Like 10 years ago, I made an investigation where I used Clang and checked test cases in cppcheck that has buffer overflows. And Clang only found about 50% of the buffer overflows. And then I did the opposite. I ran cppcheck on the Clang test cases that has buffer overflows. And cppcheck only found 50% of the buffer overflows. So there is overlap, but there is considerable reason to run both tools. Okay, how do you configure cppcheck to run clang-tidy? You first need to provide a compile commands.json database. And then you activate clang-tidy in 2 minutes, either in the GUI, you can click on an option called clang-tidy, or in the command line, you can write -- clang-tidy, and then you are done. So with this, every time cppcheck runs static analysis on a file, it will also run static analysis on clang-tidy. It will execute clang-tidy, and it will import the warnings from clang-tidy into cppcheck, and you will get one interface for both tools. So what features does this give you if you use clang-tidy in cppcheck? You get output format reformatting. You can easily, if you want that, format all the clang and cppcheck. Sorry, no, yeah. You can reformat all the warnings from clang-tidy and cppcheck into CSV, for instance. You can easily look at clang-tidy warnings in the GUI. You get SARIF output for clang-tidy also. And I want to mention that there are scripts that generate SARIF output for clang-tidy output already anyway. But this means you don't have to use another script. And you can reuse one plugin or script for both cppcheck and clang-tidy. You can use one IDE plugin, you can use one CI plugin, and you can use one script to generate reports. And then I think that suppressions in cppcheck are quite useful also, and you can use every suppression format with the clang-tidy also. It works. You get multi-threaded analysis, and you get an incremental analysis. This means that cppcheck, when you tell it to check a project, cppcheck will only check the modified files. It will not check unmodified files. And this can considerably speed up the analysis. So what happens with the unmodified files then? We save the results always. And then if a file is unmodified, we fetch those results and write them. So you get all the results all the time anyway. And here is an example how it looks with the clang-tidy inside the cppcheck GUI. The warnings are listed here just like cppcheck warnings. And you can suppress and hide and filter and stuff, whatever you want here. So this is a summary. We have talked about, I really feel that everybody should use static analysis. And we have talked about how to integrate cppcheck. And then we talked about cppcheck and clang-tidy. And base reason here, I feel that you should use several tools, no matter if it's clang-tidy or something else. And I think in the future, using SARIF, it will be more easy to use several tools. Okay, thank you.
Hey, Daniel. Are you able to use, I'm also Dan. Are you able to use like environment variables or path settings that sort of genericize your settings for cppcheck? Does that make sense?
We don't have much.
Okay.
But in your script, you can do that. But yeah, that's a good idea.
Hi, nice talk. Is it currently under the hood based on generative AI or is still using the old way?
Sorry, is it?
Currently based under the hood on the generative AI like Copilot. I have seen Copilot.
Yeah, it's provided by VS Code, I believe. So it's not provided by plugin directly, but so the VS Code, no matter what plugin you install, you will get this. So it's a common VS Code functionality.
Is it compatible with Bear?
Yes, definitely you should use Bear, I believe. I recommend it.
Thanks for the talk. Is there a reason, well, I don't know, maybe this is just your use case, but do you recommend maybe for like CMake-based projects integrating it into as part of like that system? Because there's ways to run cppcheck alongside your build automatically with CMake. Have you used that workflow, or do you just like prefer running it or having it auto-run as part of an IDE instead of being invoked by CMake? What are your thoughts on that?
Yeah, so CMake has integration with cppcheck, so you can run it alongside with the same. Yeah, I know some people configure it this way, and it can be a good. Personally, I usually use the compile commands database instead and run it separately.
So you run it manually, like you generate that database and then run it manually on that. I see. Okay, thank you.
Okay. Okay, thank you so much, everybody.